How do you map a galaxy with over 100 billion stars when you're stuck on just one rock orbiting the sun? The answer? You launch a telescope into space and make it stare at the sky for a decade, and you get the most accurate star map in human history. That's what Gaia Space Telescope did. It changed how we see the Milky Way forever. But now, it's shutting down. Why? What to discover, and what's next? Let's find out. So, what is Gaia and why does it matter? Gaia Space Telescope launched in 2013 by the European Space Agency, which is Europe's equivalent to America's NASA. Gaia's goal was mind-blowing: create a 3D map of our galaxy with unprecedented accuracy. We're talking the positions of over 1.8 billion stars, including the velocities and directions they're moving, the brightness, their temperature, even their chemical composition. Before Gaia, astronomers had to use small sample sizes and lots of guesswork to understand the shape and behavior of the Milky Way. But after Gaia, we're seeing structures, substructures, streams of stars from past galactic collisions with the Milky Way, and even dark matter fingerprints. It's not just a camera, or just a telescope either. It's a galactic census taker, tracking stellar populations like a celestial Excel spreadsheet or something. So, how did Gaia pull this off? Essentially, it orbits around the L2 Lagrange point, which is a super stable Lagrange point around Earth, but it's still relatively far from Earth's heat and light pollution, which gives it a super stable environment. Then, it uses two telescopes fixed at a wide angle to scan the sky in different directions. Then, its gigantic CCD camera has nearly 1 billion pixels, one of the largest ever sent into space. To contrast, the Hubble Space Telescope has about 8 million pixels. Lastly, it scans the sky continuously, called an all-sky survey essentially, building a dynamic map as the stars shift and seeing it in real time. The result? It can detect shifts in a star's position as small as the width of a human hair. Except, it can do it from over 1,000 kilometers away. That's pure insanity. That's crazy. Now, let's go into some of the pictures and mind-blowing images and data that Gaia gave us. Gaia's main legacy is in its star catalog, which is incredibly detailed datasets showing positions and motions of nearly 2 billion stars. Astronomers use these star catalogs daily to cross-match with other catalogs and get more accurate positions for the stars, or maybe get more accurate chemical compositions sometimes. Here are some visuals that went pretty viral in the astronomy world. Here we see the Gaia Milky Way Star Map. This shows 1.8 billion stars observed by Gaia's satellite. This was released as a part of Gaia's early data release 3. Gaia had 3 data releases. This is of the latest one. As you can see, brighter regions represent denser concentrations of bright stars, while darker regions are essentially patches of the sky where less stars are observed. Horizontal structure here is the plane of our Milky Way galaxy, and you can see it is a flattened disk that contains most of the galaxy's stars, and in the middle of the image, you can see the extra brightness of the galactic center. You can play with this interactive map yourself and look around by checking out the link in the description that I've put, named Gaia Milky Way Star Map. Here, we see the best Milky Way map by Gaia. This is an artist's impression, however, but it's based on extensive data from the Gaia Space Telescope. Using the slider, you can sort of map the different arms of the Milky Way galaxy, and it gives you distances as well, while also you can see on the side the Sagittarius dwarf galaxy. Over here, we see an image of Omega Centauri, which is a globular cluster, one of the largest, if not the largest, that we can see from Earth, and a great example of a typical cluster. You can see here stars of varying brightness, ranging from magnitude just below what we can see with our naked eye to those over 1 million times fainter. Except Gaia is different. Gaia can definitely see that stuff. Here you can see about 530,000 stars that Gaia had not seen before in its earlier data releases. This picture here was released as a part of Gaia Data Release 3 again. Sure, maybe these pictures aren't as pretty as the ones Hubble had taken, or maybe some of the ones you've seen that James Webb Space Telescope take. But they're scientific gold. Researchers use them to track dark matter, galactic mergers, and stellar evolution. Having a map of all the stars in the Milky Way, or as many as we could get, is a treasure trove of data. Okay, so if Gaia is cracked at its job, why is the European Space Agency shutting it down? Well, they're not completely shutting it down. They're essentially transitioning it into a safe mode by the end of 2025. This is because Gaia is starting to run out of fuel and resources. Gaia originally was only designed to last 5 years, and it's already essentially crushed 10 years of work. Basically, the telescope is aging, its systems are degrading, and the European Space Agency wants to preserve the final data before things get a little sketchy. It's a graceful exit, not a sudden shutdown. It's sort of like the old saying, leave the sport before it leaves you. It's retiring at its peak, instead of waiting for it to start becoming too old. What comes after Gaia? Now, Gaia may be winding down, but its legacy is just beginning. Like I said, its massive catalog of star positions, motions, and compositions is already being used in dark matter mapping, finding exoplanets by detecting stellar wobbles, stellar archaeology where we trace ancient stars to learn how the Milky Way formed, and even finding out the expansion rate of the universe. And while Gaia isn't being replaced exactly, it's passing the torch. Upcoming missions like NASA's Nancy Grace Roman Space Telescope will expand on Gaia's measurements with infrared precision. Next, ESA's Euclid mission, which was launched in 2023, focuses on dark energy and large-scale structure using Gaia's star maps as a base layer. And of course, upcoming ground-based telescopes like the Vera Rubin Observatory will do sky surveys that complement and extend Gaia's work. So while the spacecraft itself might stop scanning, Gaia's data will keep science busy for many decades. So yeah, Gaia didn't just take space selfies. It mapped our galaxy in 3D and revealed how stars move. This helped us rewrite how we think about the Milky Way, and astronomers used the extensive Gaia data released over 3 data releases to complement and boost astronomy research. If you want to dive deeper into Gaia's discoveries or how it's changing astronomy forever, or if you want to dive deeper into a different telescope and how it changed astronomy, hit that like button and comment below which telescope you'd like to learn more about. Keep expanding your universe, guys. See you next time. Don't forget to like and subscribe. It's free, and you can change your mind at any point in time, and it really helps me out as well.